All right, so these are questions 6, 7, and 9. I skipped over 8 because I don't really understand it fully, so I'm not going to make a video before I actually know what's going on. I know how to do it, I just don't know why that is the process. So I'm going to just do 6, 7, skip over 8, and go straight to 9. Now, these are pretty easy. Number 6 is how many milliliters of 0.8 mole CuSO4 molarity CuSO4 must be diluted to make 866 milliliters of 0.2 mole molarity CuSO4. So here we got two concentrations, 0.8 and 0.2, one volume, 866. So we can use the formula C1V1 equals C2V2, where C1 is the first molarity, so 0.8 right here, times V1, which is what we're trying to figure out, how many milliliters, equals C2V2. So the second concentration and the second volume. So second concentration is 0.2 equals 0.2 times the second volume is 866 milliliters. Now, usually you got to be careful because they might ask you for liters or they might give you liters and you'll be using milliliters or something. In this case, the question asks specifically for milliliters. So we can just work out 0.2 times 866 equals 173.2 equals 173.2 0.8 times V. That's going to be the same. Now we just solve for the volume. So 173.2 over 0.8. So when you work that out, you get V, or volume, equals to 216.5 milliliters. 216.5. Is that right? 216. Yes, that's right. Okay, so you need to add 216.5 milliliters. Next, number 7, a stock bottle of aqueous sulfuric acid indicates that the solution is 90% H2SO4 by mass and has a density of 1.2 grams per milliliter. Calculate the molarity of the solution. A couple of things we got to remember is that molarity, okay, molarity or concentration is N over L, where N is the number of moles, okay, and L is liters. Now, number of moles, we've seen this before. Throwback to stoichiometry, we got to convert from moles to grams to formula units to atoms to grams, back to grams or whatever. So what they're giving us here is 1.2 grams of per milliliter with the density, and they give us that it's 90% H2SO4. So we can actually use 1.2 grams per milliliter. Let's say that there is 90% H2SO4 in that 1.2 grams per milliliter. We can use the percentage that they give us, 1.2 grams per milliliter, multiply that times not 90%, but by 0.9. So you can't multiply it times 90 because 90 is a percentage. We need to use the decimal point. So 1.2 times 0.9 should give you 1.08 grams. Okay, because basically, for every milliliter that this solution has, 1.08 grams of that is going to be H2SO4, right? So if you do 1.08 divided by 1.2, you should get 90%, all right? So now we've got 1.08 grams of H2SO4. Okay, and now this is where I mentioned that little throwback. We got to go from grams of H2SO4 to the number of moles. So we can calculate the molarity. That's why we want that. So 1 mole of H2SO4. If you remember, hydrogen is 1.008. There's 2 of those, so you got to multiply. 2.016 is the weight. S, sulfur, weighs 32.06 grams. And finally, O4, oxygen weighs 15.999. So you got to multiply that times 4. Or if you just use the, what do they call it? When you round up those numbers, 1 times 2 plus 32.06 plus 16 times 4. Or either way, you should get something like 98.072. So 1 mole, so it's right here, 1 mole H2SO4 over 98.072 grams H2SO4. So here we go. Grams cancel out grams. There we go. And we end up with the moles of H2SO4. So we're pretty much done after that. If you do this 1.08 divided by 98.072, you should get something like 0.011 equals 0.011 moles of H2SO4. We're not done yet though, because remember, molarity, which is what they're asking us for, is the number of moles divided by the liters. So here at the beginning, remember I said we can assume that there's 1 milliliter, so 1.2, over, 1.08 over 1.2, because we're assuming that it's only 1 milliliter. So 1 milliliter in liters is really 1 milliliter in liters is really 0.001. If I'm right, 0.0. Okay, yes, that's right. 0.001 liters. So that's the number we got to use to calculate molarity. So 0.011 moles of H2SO4 over, we have not a liter, but we got 0.001 liters. And this will give you an answer of 11 M. So I'm just going to put it down here. 11.0 M H2SO4. There we go. Okay. Just circle these real quick. Answer for this one. Answer for this one. Finally, number 9. What volume of water must be added to 50 milliliters of 6 molarity HCl I still don't know. In order to reduce its molarity to 0.4 m. Okay, so for this one, we've got C1 equals C1 times C2. Oh my God, Jesus Christ. C1 times V1 equals C2 V2. Oh God. Okay. C1 V1 equals C2 V2. Now, the volume is what we don't know. Must be added to 50 milliliters of 6M. This is 50. Okay. Is the volume. And then we got 6 is the concentration equal to C2V2. What volume of water must be added? So the volume is what we're looking for. So that's going to be just V. In order to reduce its molarity to 0.4, that's the molarity we're going to end up at. So that's concentration to 0.4. All right, we work this out. 6 times 50. Oh my God, that's easy. 300. All right, right? 6 times 5 is 30. Okay. 300 equals 0.4. Oh my God, I hope you guys can see that. Hold on. Let's see. Okay, yeah, you can see that. Come on. Okay, 300 equals 0.4 volume. Okay, and then divide 300 by 0.4. That's going to give us 750. Let me just make sure. 300 divided by 0.4, 750. That's right. Okay, 750 equals the final volume. Now, remember, this is the final volume, or V2, but we've already got 50 milliliters. So from here, those 50 milliliters, we already had them, but they want just the volume of water that must be added. So from those 750 milliliters, we need to subtract the 50 milliliters that we already had so we can find the X amount of milliliters that we added. So, I mean, pretty easy. 700 milliliters. So 700 milliliters must be added in order to bring down a 6.0 m HCl to 0.4 m. All right.